Good morning. Today we are going to learn about life cycle of machine learning. We know that machine learning is a model where we are going to provide the input. It can read the input and find out the pattern. From the pattern, it can provide prediction from the upcoming data or unseen data. This is the basic of ML. In the ML, we are having the types of ML like supervised learning, unsupervised learning, reinforcement learning, where if you are going to use the labeled data like regression or classification, it comes under the category of supervised learning. If suppose you are going to work on unlabeled data, for instance, clustering or association, it comes under the category of unsupervised learning. If suppose you are going to work it out in a real-time environment through reward or fine, this belongs to reinforcement learning. This slide shows that overall life cycle of machine learning. First stage, we are having the data collection or collecting the data from various heterogeneous sources. Second, preparing the data. Third, analyzing with the exploratory data analysis or EDA. Fourth, building a model. Fifth, evaluating the model. Sixth, deploymenting the model. Seventh, monitoring and maintenance of the model. Where the data collection, it refers to the collecting the data or gathering the raw data from various sources. Second, preparing the data, it refers to the cleaning the data, transforming the data in one format or organizing the data from various places. EDA refers to understanding the data patterns and relationship between them. Model building, it refers to by using the ML algorithms, we are going to build the model or train the model. Model evaluation, by using the performance metrics or assessment, we are going to evaluate the builded model. Deployment, it can refers to the integrating the build model into a real world environment. The final stage refers to the we are going to ensure continued model accuracy and performance in a longer time. Now we are going to see one by one. This is the first stage called collecting the data from various sources. First, identify the appropriate data sources based on the problem. It may be from databases or APIs, sensors, even user inputs, etc. Second, ensure relevance and completeness of the data, where if suppose you are going to collect the data, this data doesn't have any association with your problem domain or problem statement meant, the entire data collection phase will be wasted. Then we have to make a concentration about the types of the data we are going to collect. The types of data may be structured data, semi-structured data, or unstructured data. Where if your data is available in the form of rows and columns or tables, this is called as an structured data. If suppose your data doesn't have any structure, you are going to collect the data like image, video, audio. It belongs to unstructured data. And another one is, and we are having a special type of formats available in the web, like a XML format or JSON format. Then it belongs to semi-structured data. For collecting the data from various places, we are going to use n number of tools like web scraping tools. We are going with special kind of an API, or we are going to collect directly from the open source websites like Kaggle, UCI, or any UCI ML repository. This shows that the stage 2 called data preparation. We do not assure that all the incoming data or all the collected data is a cleaned one. It may be a dirty data. To convert this dirty data into a cleaned data, we have to do some process. Those are cleaning the data or data cleaning. Second, handling the missing values. Third, data transformation. Fourth, feature engineering. So cleaning the data, it involves removing the duplicates, correct the inconsistencies, and filter out the noise. Handling the missing values, it includes deletion or providing the mean or median value in the missing values, and then we are going to predict. Data transformation, where if suppose we are going to work it out with the two different datas, what we are going to do is we are going to transform all the data in only one format. This refers to the data transformation. Some of the frequently used techniques are normalization, scaling, encoding a categorical variable. Finally, we are also employed with feature engineering, where it involves creating a new relevant features to enhance the model performance. Sometimes we are the collected data will be very minimal or very small. Then we are going to apply this kind of an feature engineering. Stage 3, it involves data exploration or EDA. For building a better model, we have to understand the data in depth. This type of data exploration can be used for understanding the data in a depth manner, where we are going to understand the data distribution and the trend of a data and the correlation between the data. Some of frequently used tool in this kind of data exploration are histograms, box plots, scatter plots, and correlation heat map, where this is especially used for detecting the outlier and anomalies by using statistical methods. Some of the frequently used libraries or tools are Pandas, Matplotlib, Seaborn, Plotly. These are belongs to Python, and either we will go for Tableau or Power BI. Stage 4 is called as an building a model. After EDA process, after data cleaning, we are going to build our model. So building a model, it refers or it directly refers to which algorithm or which ML algorithm we are going to apply. Like choose algorithms based on the problem type. Like either you are going with the problem type of classification or regression. If suppose you are going to have a problem type of classification, then you are going to apply the algorithm of a regression, meant your entire ML model will be getting failed. So that we have an awareness that if the problem statement must be equivalent to the algorithm. Then split the data set into training data set, validation data set, and test data set, where some of a part of data will be used for training the model and some of the part will be used for testing the model. This is the reason why we are going to split the entire data set into training, validation, and test set, and then train the multiple models and tune hyperparameters. So here hyperparameter tuning refers to tuning the parameters of the particular algorithm. If suppose you will take an support vector machine as an ML algorithm, support vector machine can have a inside parameters, three parameters, where I'm going to change the kernel of support vector machine. This belongs to the hyperparameter tuning, or else we will go for cross validation to reduce overfitting and evaluating the generalizability. The stage 5 refers to the evaluating the model. So there will be a common performance metrics is available in a machine learning, including accuracy, precision, recall, F1 score, ROC or AUC. So these are all belongs to a concept called confusion matrix, which is used to interpret the classification result. Either my produced result of ML model is how much percentage it can have accuracy. Like 80 percentage of accuracy, it refers to 80 percentage of a success and 20 percentage of a failure. So in a similar manner, we have to evaluate our build model, and we have to compare performance of a different models to select best one. Stage 6, it refers to the deployment of a model. Once if you assess your model a very successful one, then we have to deploy the successful model to the client side. Like choose deployment method, either we will go for batch processing or REST API or any kind of an embedded systems. And also we will integrate model with applications like from websites or to the mobile applications or to the enterprise softwares. Ensure performance, security, and scalability. This is called as an deployment. The frequently used tool for this stage 6 is either we will go for Flask, Fast API, Docker, Kubernetes, or we will go for some cloud platform for better deployment. Stage 7 ensures that monitoring and maintenance of a successfully deployed model, where we are going to track the performance of the model in production using the dashboards and logs. Direct model drift. If suppose there will be any changes in the model, we have to monitor. Then schedule periodic retraining with the updated data. Then finally, ensure ongoing data pipeline functionality and model responsiveness. If suppose there will be a problem in the responsiveness of a model, we have to take a action or we have to work it out with the model. Thanks for listening.